Okay, so we have a foldable over proportional and non-proportional relationships. I'm going to go ahead and start at the bottom. If you notice, all three of these different parts of our foldable, it will be considered proportional, versus the top portion will be non-proportional. Okay, so starting with the proportional side, this is definitely a review of what we've already covered. But proportional relationship is also known as direct variation. You might have seen that title on your Think Through Math when you guys did Think Through Math, which is the same thing as your constant of proportionality. Okay? Which also we just covered with our last unit. So for the example, it says, for his birthday, Bert wants to take his friends to the movies. Each ticket costs $2.50. How much was the total bill? So I would have a fixed amount and a varying amount. The fixed amount would represent my constant. If there was an entry fee or it costs you something no matter what, like the one-time fee, that would be our fixed amount. But in this case, we do not have a fixed amount, so our fixed amount is 0, which represents your B. And our varying amount is $2.50, and that's varying because it depends on how many people are coming along to the movies with Bert. So that will represent my M. So I'm going to take this information and I'm going to put it in my table. So I'll start off with the table. So if I if I had 0 number of attendees, about what would be my total cost? In this case, my total cost would also be 0 because I didn't need to buy any tickets if I didn't have anyone there. That also represents my B. Okay. If I had 1 attendee, the cost would be $2.50. If I had 2 attendees, $5. 3 attendees, $7.50. And I'll just go ahead and put this information in my ordered pairs. So when X was 0, Y was also 0, which identifies my B. Okay. When X is 1, Y was 2.5 or $2.50. 2, $5. 3, 7.5. So if I needed to identify my constant rate of change or my slope, I would do my delta Y over delta X. So my change in Y ranged from 0 to $2.50, so that went up to 0.5. And from 0 to 1, it would just be 1. And I only need to pick 2 ordered pairs. I'm sorry for my screen. It'll come back. So my change in Y is 2.5. And my change in X is 1. So therefore, my slope is equal to 2.5. Okay, since I've already set up some ordered pairs for my graph, I'm going to go to my graph next. On my y-axis, I think I'm going to go ahead and label it going up by 2.5. So that'd be 2.5. That's 5. 7.5. What would be the next one? 10. And so on. And then my x-axis, this will be 0, 1, 2, 3, 4, 5, and so on. So when I had 0 number of attendees, I was at $0. So that's my first point. 1 attendee, $2.50. 2 attendees, $5. 3, and if you will see, this will continue on in this fashion. I will take a ruler, and because these are linear equations, I should draw a line. And you will notice that my line, as soon as the video come back, my line will go through my point of origin. Okay, my graph will go through my point of origin. That's my poo. It will graph through my poo. So therefore, it is a proportional relationship. Okay, also taking the points that I've gained from the table, we're going to create an equation. Noting on proportional relationships, the B will always be 0. Your B will always be 0. So there's no need for me to write that down. So I can do my Y equals $2.50 times my number of attendees, and that's it. This is the same thing as saying Y equals MX, or like we've learned on constant proportionality, Y equals KX, because it is proportional. Because the B is 0, I don't have to write the B. Okay, so those are my proportional relationships. We're going to go to the non-proportional relationship. It says Ernie went to the fair. Admissions was $3, and each ride tickets were the ride tickets were $2 each. How much money did he spend? So my fixed amount in this case will be my admission because I have to pay to go to the park. So that'll be $3. That represents my B. And my varying amount, or the amount that will always change, is the $2 because it depends on how many rides I ride. So I'll take this information and go to the table. If I didn't write anything, I have a total cost of $3 because I have to pay for admissions. So that's me not writing a thing. I don't write anything. If I ride one ride, I have to pay the $3 for admission and $2 for that ride, so I would spend a total of $5. If I rode 2 rides, I would have spent $7, and 3 rides, $9. So remember from last week when I gave you notes over a table, when I have my X is 0, it will identify my B, which is 3. That's how I know that this is a non-proportional relationship, because I have a 0 and 3. But my other ordered pairs is 1 and 5, 2 and 7, 3 and 9. So I need to find my slope, so I do my change in Y, which is plus 2, and my change in X, which is 1. Change in Y over change in X, 2 over 1, which equals 2. And I'll come back to this when we create our equation. So let's go ahead and go to our graph. And I'll label my x-axis, which is my number of rides, 0, 1, 2, 3, 4. And then the total cost, and that's 0, 1, 2, 3, 4. And I'll label up to 9. So when I came to the park and I have not rode anything, my total cost is already $3. So when my X is 0, my Y has a value. 1 ride, $5. 2 rides, $7. 3 rides, $9, and etc. And if I draw my line, we'll notice that it does not go through the pool. Okay, it will not go through the point of origin, so therefore it is non-proportional. Okay, in my equation, we know my B is 3 because we've identified it here. But just kind of review, when I'm creating my Y equals MX plus B in a non-proportional relationship, my B will never be 0. So it's just opposite of proportional relationship. My B will never be 0. But if I know my slope is equal to 2 that I got from the table, I know I have y equals 2x. I'll start there. I can plug in my values for x. Y equals 2 times 1. 2 times 1 is 2. How do I get from 2 to 5? I would just simply add 3. And that will be true for all of them. 2 times 2 is 4. From 4 to 7, I have to add 3. 3 times 2 is 6. To get from 6 to 9, I will add 3. So that creates my equation here. Okay, these things will be useful for you in your project. In your project, you do have to create a word problem that represents a proportional relationship and a non-proportional relationship. Here are 2 examples. You may not use these in your project. I've created tables from this relationship. I created a graph and an equation, which you also have to do in your project. So what I want you to do now is go ahead and fold each side in. Hopefully it folds right if you cut it right. And on the top, you will label it. Let me label first, and then I'll show you guys. Proportional versus non-proportional. Linear relationships. And my camera will come back alive in just a second. There we go. Proportional versus non-proportional linear relationships. If you put the glue on the very back and glue it in your notebook, it should look like a flower when you kind of open it all up. And again, let me fix my camera. I'm sorry. Proportional versus non-proportional linear relationships.